You don't get 100% yield. Why? Not all the material reacts. Okay? In grade 12, you learn how to push reactions to completion or further along the path, but not everything will react all at once because the activation energy might be too high or whatever. You might have impure products or impure reactants, sorry. Okay, so you're not going to get what you theoretically expect. Or you mess up the collection. All right, when we collect gas, when you're doing a titration like we're going to do tomorrow, you might have, there's human error involved in this. All right, so the theoretical yield is what stoichiometry predicts. That's what we've been doing. If you react 5 moles of this, how many moles of the product do you get? That's stoichiometry. That's the theoretical. The actual is what you get in the experiment. Okay? What you actually collect when you do the physical experiment. It's rarely, if ever, 100%. Okay? To get the percent yield, it's how much you got, the actual yield, divided by what you theoretically should have got, times 100. That's it. We're going to look at percent purity. We'll probably do that on Thursday. So let's just do the percent yield calculation right now. So if you flip the page, 15 grams of methane, CH4, is reacted with an excess of Cl2. If you react with an excess of something, does the something that is in excess ever run out? No. So you don't really need to worry about it. This methane will be the limiting. Okay? So this is the limiting. So when I don't want you to worry about the limiting reagent, I'll say you react A with an excess of B. And then you don't go, okay, I know A is the limiting reagent. Okay? According to the following reaction, a total of 29.7 grams of CH3Cl is formed. What is the percent yield? Okay, this is how much we got from the experiment. What we need to calculate is how much should we have gotten. Okay, so the expected or the theoretical would be you react 15.0 grams of methane, CH4, molar mass of methane is 16. So 1 mole of CH4, 16 grams. So now we got moles of methane. Now we're walking across our mole bridge. Everything is 1-to-1 in this reaction. So that is 1 mole of methane is 1 mole of CH3Cl. But we don't want moles of CH3Cl. We want grams because what we measured in the final product in the experiment was in grams. Chlorine is 35. Carbon is 12. That's 4750. 55.5? 50.5. 50.5 grams of CH3Cl is 1 mole of CH3Cl. And then the grams cancel, moles cancel, moles cancel. So we're left with grams. Punch that in your calculator and 47.34. That's what we expected, or theoretically what we should have gotten if we reacted 15 grams of methane. We only got 29.7. Therefore, percent yield is 29.7 divided by 47 point, should be 3 sig figs times 100. $62.8%. Does that make sense? Peoples? All right. We can do one more question, then we're done. Reaction has a 76% yield. 1.5 grams of KO potassium oxide is reacted with an excess of CO2. So don't worry about the CO2. What mass of K2CO3 is produced? So essentially, if you think about the math from a math percentage or a math point of view, percent yield is actual over expected or theoretical. We know what the percent yield is. It's 76%. They're asking us what mass should we get? Okay, so they're asking for the actual. So what do we need to figure out before we can solve this? We want to figure out the expected result. That's what we want to find out. And then we can plug it into that formula and figure out the actual yield. So the expected. 1.50 grams KO2. What's the molar mass of KO2? 71.5? 71.1? Thank you. There's 1 mole of KO2. Go across the mole bridge. That's a 2-to-4 ratio. What's the molar mass of K2CO3? 99.1. Thank you. So 1 mole K2CO3 is 99.1 grams. $1.04. Is the molar mass wrong? 130. Okay, what does that give me, Alicia?
Oh, you know what went wrong? I forgot a potassium.
1.458 grams. Okay, 1.458 grams is the expected. So then it's just plug it into here. 0.76% or 76% of the times the expected will give you the actual. And when you put 76%, it's 0.76. Yeah, you should be 1.46. You're right. So 1.11. So you actually got 1.11 grams. Does that make sense? We burned through that a million miles an hour. We'll do that on Thursday. Tomorrow's a lab. quiz on Thursday, but we can talk more about that tomorrow.